everyone, my name is Daza and I'm from Presiden University and I'm majoring in Environmental Engineering batch 2021. In this presentation I will tell you about the application of green chemistry and then the content that we will discuss or I will tell you is about what is green chemistry, the principles of green chemistry, and the benefit of green chemistry. And the last one is application of green chemistry in daily life or in domestic. Next. Of course, we will talking about green chemistry, and then we must know what is green chemistry. So, what is green chemistry? Green chemistry is the design of chemical products and processes that are more environmentally friendly and reduce negative impact to human health and the environment. So, after we know about what is green chemistry, we will also learn about the principles of green chemistry. And for your information, there are 12 principles of green chemistry. The first one is prevention. It's better to prevent the production of waste than to treat or clean up waste after it has been treated. And with these principles, it's advantageous to carry out synthesis in such a way that the formation of waste products is minimum or absent. The waste is discharged in the atmosphere, sea, and land can cause not only pollution but also requires expenditure for cleaning up. And the second one is atom economy. So, synthetic methods should be designed to maximize the incorporation of all materials used in the process into the final product. Example, reduce waste at the molecular level. Next, next is minimization of hazardous products. In this case, wherever practicable, synthetic methods should be designed to use and generate substance that possesses little or no toxicity to human health and environment. And the next one is designing safer chemicals. In this case, chemical products should be designed to effect their desired function while minimizing their toxicity and environmental destiny throughout the design of the process. And number 5 of the principle of green chemistry is safer solvents and auxiliaries. So in this case, we can choose the safest solvents available for any given step and avoid whenever it's possible. And the next one is design for energy efficiency. In this case, we can choose the least energy demanding chemical route, like ambient temperature and pressure are optimal. And the seventh principle of green chemistry is use of renewable feedstock. In this case, we can use chemicals which are made from renewable resources like plant-based, rather than chemicals originating from depleting resources. And the number 8 principles of green chemistry is reduce derivatives. In this case, we can minimize the use of the temporary derivation such as blocking group and protection group. And the next one is catalysis. In these cases, we can use catalysis reagents as selective as possible, rather than stoichiometric reagents in reaction. And the number 10 of principles of green chemistry is design for degradation. In this case, design chemicals that degrade and break down into harmless products which do not persist in environment at the end of their function. Next, it's the real-time pollution prevention. In this case, we monitor the chemical reaction in real time, then process and control prior to the formation of hazardous substance. And the last one is safer chemistry for accident protection. In this case, in this principle or in this case, we can choose and develop chemical procedures and substances that are safer and minimize the potential for chemical accident, explosions, and fires. And here are some of the fields involved in everyday life where green chemistry has been applied to some extent. Next, it's about the benefit of green chemistry. As we know that green chemistry is really good for our environment, not only for an environment but also for our health. So, in this slide, I will tell you some benefit of green chemistry and why we should apply green chemistry in daily life. First, why we should apply green chemistry in our daily life because it has so many impact or benefit to our health and to our environment. And I put in here three benefits of green chemistry. I only put three benefits of green chemistry. So, for the first benefit is cleaner air. Why we get cleaner air? Because it's release a less of hazardous chemicals to air leading to less damage to lungs. And then we also get a cleaner water. Why? Because the release of hazardous chemical is less to water leading to cleaner drinking and recreational water. And the next one is safer food. Its elimination of a persistent toxic chemical that can enter the food chain, severe pesticides that are toxic only to specific pests and degrade rapidly after use. Next. Okay, so we will talking about the application of green chemistry. Like I said before, that green chemistry is really important and really useful if we apply this green chemistry in our daily life. So there's some example of application of green chemistry in our daily life. So for the first one is the green dry cleaning of clothes. Perchloroethylene or perch is the solvent most commonly used in dry cleaning clothes. It's a new technology known as missile technology, was developed by Joseph DeSimons, Timothy Remark, and James Mack. Clay in which liquid carbon dioxide can be used as a saver solvent along with surfactant to dry clean clothes. This method is now being used for commercially by some dry cleaner. And then dry cleaning machines have been modified for using this technology. Uh, carcinogen perch or perchloroethylene is replaced by green solvent. Next, the second example of applied green chemistry in daily life or domestic is green bleaching agents. So, um, conventionally, during the manufacturing of good quality white paper, lignin from wood used for it is removed by placing small pieces of wood into a bath of sodium hydroxide and sodium sulfide, followed by its reaction with chlorine. In this process, chlorine is also react with aromatic rings of the lignin to form the chlorinated dioxide and chlorinated furans. These compounds, being carcinogens, cause health problems. And and Terence Collins of Carnegie Mellon University developed of a green bleaching again, which involves use of H2O2 as a bleaching agent in the presence of some activator such as a TAML, which catalyzes the fast conversion of H2O2 into hydroxyl radicals that cause bleaching. This bleaching again breaks down lignin in a shorter time and also at much lower temperature. It can be used in laundry and result in lesser use of water. And the third example of application of green chemistry in domestic is eco-friendly paint. So, uh, oil-based alkyd paints give off a large amount of volatile organic compounds or VOC as it dries and cures. These VOC have many environmental effects. Procter and Gamble and Core Composites and Polymers stabilize a mixture of soya oil and sugar to be used in place of petroleum, petrochemicals derived paints resins and solvent which reduce the hazardous volatiles by around 50% Campbell MPS. Paint formulation use these bio-based pose oils to replace petroleum-based solvents and create paint which is safer to use. Sherwin-Williams stabilized water-based acrylic paints from recycled soda bottle plastic or PET, acrylics, and soybean oil. This paint gives performance benefit of alkyds and low VOC content of acrylic. In around 2010, enough quantity of this paint were manufactured to eliminate around 362.874 kilograms of VOC. And the fourth example of application of green chemistry in domestic is turning turbid water clean in green way. So, um, conventionally, municipality and industrial wastewater is made clear by the use of alum. The tamarind seed kernel powder, which is discharged as agriculture waste, has been found as effective and economic agent to make municipal and industrial wastewater clear as with alum. So and also tamarind kernel powder is as we know is non-poisonous, biodegradable and economic. And in a study, four flocculants tamarind seed kernel powder mixture of the powder and starch alum were taken, and flocculants with slurries were obtained by mixing lesser amount of clay and water. The aggregation of the powder and suspended particles were found to be quite porous, which permitted to the water pass through it, and it also became compact more easily, and thus larger volume of clear water was obtained was obtained. And then starch flocks, being lightweight and less porous, didn't allow water to pass through it easily. The study established that the powder has potential as a effective flocculant, having a performance like more stabilized flocculants such as potash alum. And the next one is the next example from application of green chemistry in our domestic is biodegradable plastic. So right now, many companies have been working in this direction. The company is trying to use the raw material from agricultural waste. In another example, BASF developed a biodegradable polyester film called as Ecoflex. This film or this Ecoflex is used along with cassava starch and calcium carbonate to make fully biodegradable bags called as EcoFio. The bags are certified by the Biodegradable Products Institute as completely biodegradable into water, CO2, and biomass in industrial composting system. These bags are also found to be tear resistant, puncture resistant, waterproof, printable, and elastic, so it can be used in the place of conventional plastic bags. Um, and also, this plastic will quickly degrade in municipal composting system, along with kitchen and yard waste. And and the next one is the example of apply green chemistry in domestic field or in daily life is a solar cell. As we know that the solar cell is the most important example of green technology and it directly converts the light energy into electrical energy by the process of photovoltaics. And solar photovoltaic technology has been found to be one of the few renewable, low carbon producers with both the scalability and the technological development to congregate the ever-growing global demand for electricity. The use of solar photovoltaics has been rising at an average of around 43% per year since 2000. And generation of electricity from solar energy result in less consumption of fossil fuels, reduction of pollution and greenhouse gas emission. So it's really important uh, or to apply solar cell in our environmental because it can reduce of pollution and greenhouse gas emission. Next, so the last example of application of green chemistry in daily life or in domestic is building with green technology. Green buildings make use of a variety of environmentally friendly techniques in order to reduce their impact on the environment. So, as you see in this slide, there's a picture that the green buildings is use a technique that really environmentally friendly and reduce negative impact to our environment. And green technology also use of domesticated materials and reflexive solar design and natural ventilation and green roofing technology may allow builders to construct a building with a significantly smaller carbon footprint than normal construction. So, uh, green technology or green building is produce a smaller carbon footprint than normal construction that not use green technology or green chemistry. So, this technique or this green technology are beneficial for the environment as well as they can produce the cost-effective building which are healthier for the occupants too. Green ventilation technique reduce the need for traditional air conditioning by allowing natural airflow to get in the room. So we already at the end of the presentation. of the application of green chemistry, and we already know about what is green chemistry, and we already know the principles of green chemistry, and there are 12 of principles of green chemistry, and we already know about the benefit of green chemistry, and the last one we already know about the application of green chemistry in domestic and in daily life. So, the conclusion that we can get from this presentation is green chemistry is a new philosophical approach that, through application and extension of the principles of green chemistry, can contribute to sustainable development. A lot of efforts are being undertaken to design non-polluting starting materials and to get safer products without side products. The greatest challenge is to incorporate the green chemistry day to daily life. Many successful efforts have been made, but still a lot has educating new generation of chemists. So, thank you for your attention, and thank you for your mm watching this video, and I hope this video and this presentation can give you a new insight about green chemistry and why green chemistry is really important to apply in our daily life and in domestic. I hope it can give you a new insight, and thank you for your attention. Thank you.